All right, welcome to Chapter 7, Section 4, Properties of Similar Polygons. So this is for Math 8. A couple things you'll see on your screen here. The first thing you should see is a due date. I don't see that on my teacher preview, but you'll see it on your student screen. The second thing in here is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. And then number of questions. This just tells you how many questions are on this assignment. Grading policy is always best score, so whichever attempt is the best one is one to keep. Partial credits enabled, so if you answer 1 to 3 questions correctly, you get credit for 1 question, or however many you answer correctly. Please remember, once you start your homework, you must finish it before you can work on anything else. What that means is once I click start here, down in the bottom right corner, I need to make sure that I click the submit assignment button when I want to leave this screen. I know I don't see it here on my teacher preview, but you will see it on your student screen. So it does 2 big things. Just like that last screen said, it'll lock you out of all of your other assignments. Because if you just leave the screen, like by closing the tab or closing your computer, Alex assumes you want to leave this attempt open. Remember, you have unlimited attempts. There's no reason to leave this attempt open. As long as you have green check marks here, like you've actually clicked check and you've gotten them correct, it's not going to make you start over. It's going to start you back wherever you left off. So that's definitely a big one. The second one is that it affects the gradebook when you click submit assignment. So until you click that button, your account's kind of frozen. We can't even see what you've been working on. So very good idea. Always make sure you click that button. We have explanation here. Explanation tells you you're going to lose your question attempt because it's going to give you the answer to this question. So it's not going to give you the answer and then let you type it in. Example, we'll just show you an example of exactly what it is we're going to be working on. And for this one, we're going to look at similar triangles, which means they're the same shape, but not the same size. We've either increased or enlarged or reduced one of the shapes. So we made it bigger, we made it smaller. So we have to decide what's the scale factor so we can even see what they're doing here for each side. What are we dividing or what are we multiplying by? In this case, we're dividing. They're going from the larger number to the smaller number. And then to fill in the blank, we do the same thing. So this one had a blank here. So if I know I'm dividing by 6 on the other 2 sides, I have to divide by 6 on this one. So 24 divided by 6 is 4. So I just fill that piece in there. I can, once I get done with this, I can close it. I can open another example if I'd like. I can also message my teacher directly from the screen. All right, so let's go ahead and take a look at this problem. And I'm just going to steal a picture of it. Be a little bit lazy instead of having to draw it. Where is it? There it is. Just took a minute to come up here. Okay, so I'm going to do that same thing that example was showing us. We're just going to decide how do we get from one triangle to the other. And it says they are similar. I don't have to worry about whether or not they're similar. They are the same shape. It's telling me they're similar. I just need to figure out what's the scale factor. What am I multiplying or dividing by? So if we always look at the larger triangle, that makes it a little easier. So I can go from 40 to 5. I have to divide by, and so we just have to decide what am I dividing by. And in this case, I'm going to divide by 8. 40 divided by 8 gets me 5. So I'm going to do the same thing on this one here. If I want to go from 56 to 7, then I'm going to divide by, and again, if I divide by 8, that gets me 7. And what I'm looking for is the same number there. I should definitely be able to find the same number. If I haven't found the same number, I might not be looking at what's called corresponding sides. So you want to make sure, and I just kind of jumped into this without paying attention to this, but A, B, C, so it goes A, B, C, D, E, F, D, E, F, they're in the same spot. So A, D, B, E, C, F. These positions matter. A goes to D, B goes to E, C goes to F. So make sure you're paying attention to that order, because sometimes they do reverse the triangles, so just pay attention there. So we're going to do the same thing on this guy. We would divide by 8. Well, they're not giving us the larger number here. So instead of dividing by 8, I can do the opposite. If this way is dividing, well then if I go backwards, I'm going to multiply by 8. I can do both. Either way, because I can go 5 times 8, that gives me 40. 7 times 8, that gets me 56. 4 times 8 gets me 32. So that missing length is 32. All right, so let's go to the next guy here, which is, I think we're going to look at pieces. So we're going to fill them in with a fraction. So I'm going to go ahead and get a new flip book here so I can write this out. So we have AB over AC. And they want to know what is the fraction. So we're going to go, what are the lengths? AB is 6, and AC is 12. So I need to reduce this. So 6 over 12 reduces to, they can both divide by 6. So it's 1 over 2. So this is going to be 1 over 2. Like this. For AB over AC. AB over BC, they already did for us. And we can see if we did AB over BC, we would have gotten 6 over 15. They both divide by 3, which is where they got 2 over 5. They filled it in for us. AC over BC, so AC is 12 and BC is 15. So these both divide by, I think, 3 again is all they divide by. 12 divided by 3 is 4. 15 divided by 3 is 5. So I get 4/5. So in this way, we're asking, or it's telling us they are similar. And what we're trying to look at is what is the ratio of each of the side lengths of one triangle to the other. Do they have the same side lengths? So we want to take a look and say, we know that it's XZ on the bottom. We want to choose the drop down, which one it's going to be. It's not going to be XZ again. So XZ, we want it to be 1/2. So if XZ is 20 and I want it to be 1/2, well, I need it to be 1/2 of 20. So I want it to be XY. And then with this middle one, we want it to be 2/5. Remember, we're matching them up to the same fractions we had up above. Oop, and I didn't put a 5 there for some reason. So if I have XY and that's 10, and I want it to turn out to be 2/5, so I can even look at it this way, I want to say, well, what does that need to be? And I can look at it as far as like, what did I divide by here? Or what did I multiply by? I multiplied by 5 to get from 2 to 10. So I'm going to do the same thing on the bottom. Or I could use cross products. So 5 times 5 gets me 25. I could use cross products too. 10 times 5 is 50. And that's going to equal 2 times x, which is 2x. And then I can divide by 2, which would get me back to 25. So I can look at this more than one way. There's not just one way to do this problem. And hopefully, I know that was a little quick, me going through both of those options. But this is definitely a very quick way to do this. Is just say, okay, well, these are comparable. I want it to be 2/5. What do I need to fill that in with to make it true? It needs to be 25. So this guy's going to be YZ. And then we have YZ on the bottom. And I want it to be 4/5 this time. And YZ is 25. What do I need it to be on the top? So I multiplied by 5 here to get from 5 to 25. I need to do the same thing to go from 5, to move on the top. I have to multiply by 5, so that's going to be 20. So that's this guy here. So I'm just matching up those ratios. That's the main idea, what we're kind of looking at here. And with this one, it's relationships about ratios that we can match up. So we can match up the side lengths, the corresponding sides, based on the ratios that they have with each other. So it's a very easy way to match them up. So we need to choose the correct statement about the answers to part A. So in each pair of proportions, the lengths of the sides of ABC are in the same ratio as the lengths of the sides of XYZ. This is because we compared the sides of XYZ that correspond to the sides of ABC, and the triangles are similar. That sounds pretty darn good. That was a lot, but it sounded pretty darn good. So in each pair of proportions, the lengths of the sides of ABC are in the same ratio as the lengths of sides XYZ. So it's the same kind of statement they made on the top one. This is a coincidence. We wouldn't usually not expect this similar triangles that are not the same size. Well, they should have the same ratios on the side if they're similar. The ratios should have increased by the same amount. So if this is 6 and 12, it doesn't look like we're multiplying by a whole number here to get from 12 to 20. But whatever we increased the triangles by should have caused that ratio to stay the same. The ratio should not have changed. So it's not a coincidence if they're similar triangles. In each pair of proportions, the lengths of the sides of a triangle ABC are not the same ratio as the lengths of the sides of XYZ. Well, we already know that's not true. We can see that the ratios are the same. We match them up. In each pair of proportions, the lengths of the sides of ABC are not the same. So again, I hear not the same. So the only one that sounded good to me was that first one. In each pair of proportions, the lengths of the sides of ABC are the same. Ratios, the lengths of the sides of XYZ. That was true. All the ratios are the same. And this is because we compared the corresponding sides of similar triangles, which is true. Whatever we've multiplied, however we've dilated it, we've dilated them by the exact same amount for each one. So the ratio should stay the same. It shouldn't change. All right. So we have one more of these guys. So let me clear this out. All right. Oh, I thought I clicked continue. Okay, so the pentagons ABCD and PQRST are similar. So we know that they are the same shape. We don't have to worry about whether or not they're the same shape. And they do have corresponding sides. If they are similar, all we're doing is making one larger or smaller. That's all we're doing. So find the length of X. So here's X down here of ST. So we want to know what's this length here. So what we need to do is that same kind of thing that we did before. But with this one, it's not quite as easy. So I'll grab this picture here so that you can see what I mean. Because with that first pair of triangles, we just kind of did that little mapping where we said, you know, oh, well, from here to here, we divided by something. Well, to get from 4 to 5, that's not quite as easy. What do we multiply 4 by to get, or 5 by to get to 4? Or what do we divide 5 by to get to 4? So instead of using that method, what we're going to do is a scale factor. If I know, and I can even match up CD is in the middle here, RS is in the middle. So I know CD and RS are corresponding. And I can kind of see that from the shapes too. So I'm going to go CD over RS as my scale factor. So that's going to be 5 over 4. And I'm going to use this scale factor. We can actually divide this down and say 5 divided by 4 gives us 1.25. And they do give us a calculator to do this over here. So you can go 5 divided by 4, and that gives you 1.25. What that means is that to go from 5 to 4, I'm dividing by 1.25. So 5 divided by 4 equals 1.25. And if I go 5 divided by 1.25, I get 4. So this is just telling me what am I dividing by. You can also set up a proportion and use cross products on this one. Kind of just depends on preference here. But I can do the same thing here. So this is kind of the same idea we did with the mapping. We just need to look at the fraction first to find out what am I multiplying by, because it's not quite as obvious on this one. So I'm going to do the same thing. I'm going to divide by 1.25 to find X. So 4 divided by 1.25, and that gives me 3.2. So I can come over here and go 3.2 and check, and that works. You can also, like I said, you can set up a proportion using this scale factor, and then use it so that you'd end up with, so you have 5/4 equals, so 5/4 is the scale factor, and then you'd have 4, because it comes from the same one as 5, so on the top, and then over X, because that's corresponding to the 4 here, and we use cross products. And I'd have 5X equals 4 times 4, which is 16, and then divide by 5 on both sides because I want x by itself. Well, if I check this, 16 divided by 5 gives me that 3.2. So I can also use cross products here. Kind of just depends on the property that you like to use. So that was section 4. I will see you in section 5.